Hey, geometry friends, here we are in section 8.3, and we're going to talk about special right triangles. Honestly, this is probably one of my most favorite um, chapters because it talks about some things that are pretty cool. So we don't really have vocabulary terms per se, but I'm going to call some of this vocabulary. So there's some special triangles that we're going to talk about, and those triangles are two important triangles, and one would be, and they're both right triangles. And so one is the 45-45 right triangle, or basically an isosceles right triangle. So isosceles, we know that the two legs are equivalent and these base angles have to be equal. And clearly, since this is 90 degrees, these two have to add up to 90 and they are 45 degrees. And so there is a special relationship or ratio that you're going to see with the sides. And we're going to exploit that in some of these problems. And the other one is this guy. I'm drawing a little bit bigger. But it's a 30-60-90 right triangle. So where one angle is 90, the smallest angle would be 30, and that would be across from the smallest side. And then the next angle is 60 degrees. And this is an important triangle as well, where we're going to talk about the relationship with the side. So that's what today's lesson's about. So the first thing we're going to do is start off with the development of a formula for our 45-45 right triangle. Okay, so we know that it's a 45-45 right triangle. Let's say we're given this triangle we start off with, and we're told that the legs have a length of S and S. Now, according to the Pythagorean theorem, right, let's call this side the, I'm going to use green. Let's call this side the hypotenuse, which it is. According to the Pythagorean theorem, we know that a squared plus b squared equals c squared when we're referring to any right triangle, and that's not different for this either. This is a right triangle. Even though the a and b are going to be equal, we would just write s squared plus s squared equals our hypotenuse squared, right? Whatever that is. So if I wanted to figure out what the hypotenuse was, I'd have to see if I could simplify this situation here. So if I have s squared plus s squared, that's 2s squared is equal to the hypotenuse squared, right? Hypotenuse squared. And then what I do next is to figure out what the hypotenuse length was, is I'd have to take the square root of both sides. And so when I do that, I get the square root of 2s squared is equal to the hypotenuse. Not a big deal. You guys get that. And then when I take the square root of 2, I cannot really do it. So I'm going to leave it as the square root of 2. But when I take the square root of s squared, I get s. So my answer is s root 2. So that's the length of the hypotenuse. Why am I doing this? Well, I'm doing this so I don't actually have to apply the Pythagorean theorem when I run into another triangle like this again, okay? So the hypotenuse will be s root 2. So sometimes when we see right triangles, specifically isosceles right triangles or 45-45 right triangles, what we would see is this marking s root 2, meaning whatever this side length is and this side length is, right? This other side length is just going to be the same thing times root 2. So a quick little mini example would be if I had a square, and I told you that the side length of the square was 14. All right, the side length is 14, and I asked you the length of the diagonal. Instead of saying, oh, wait a minute, a squared plus b squared equals c squared, which is actually totally cool to do, you could just say, oh, it's got to be 14 root 2. Why? Because of that rule you showed us, right? So this is the relationship between the sides, and it gets a little bit more involved when we deal with that later, and you'll see in some examples in the text. We'll do some examples. So check this one out. Now we got to talk about the other triangle, that 30-60-90 right triangle. So let me draw that out for us. So it kind of looks a little bit like this. And this is a 30, this is our 90, and this is our 60. And the way you get the proof for this one, or the way we can really kind of see the relationship between the sides, is by actually drawing kind of a ghost figure on the other side. Like, what if I drew a triangle, let's say an auxiliary picture here, right? Little helping picture. So what if I just drew the same basically triangle back on this side? Do you know what kind of a triangle I would have? I'm really having trouble with this little line here. Do you know what type of trouble? Not what type of trouble. Do you know what type of triangle I would have? Hopefully, you can guess. I hear you, girl. I hear you shouting it out loud. Just keep quiet. No, I'm just kidding. We would have an equilateral triangle, right? And not more than isosceles an equiangular and equilateral triangle, because this would be 30, as would this be 30. And this would be 90, and this would be 60. And so this whole thing would be an equilateral triangle. And that gives us some beautiful things. So if this little, I know we're focusing on this triangle right here that I have shaded in red. This is where our focus really is. But we can use this information, like if I were to refer to the side opposite the 30-degree side as, let's say, S, if I were to just call that S, then I know that this side, well, this is also S, right? And since this is an equilateral, this whole side would have to be two S's. Take a minute to just breathe that in for a second. This little bit in this red triangle opposite that 30 degrees is going to be S, then this side has to be S as well. Well, if this side of the triangle, this equilateral triangle, is 2S, then this side has to be 2S, this little side here. And so now what we're going to do is just look at this red triangle and the information we have in reference to its sides. So I redrew my little right triangle there, and I'm going to put down the fact that we know that this side is 2S if this side is S, right? This side is 2S if this side is S. The question is, what's this side opposite the 30-degree side? Opposite the 60-degree side. So we want to get a full relationship with all the sides and not just two sides. So we're going to bring out, you know what we're doing? We're going to bring out that Pythagorean theorem again, and we're going to plug in what we know. So I know that one leg is S squared. The other leg, this one here, I don't know nothing about it, so I'm going to leave it as B squared, and that's what I'm going to be solving for. And this other side, C squared, will be 2S quantity squared. You see what I did? The side squared. And so now if I use my algebraic talents, S squared plus B squared is equal to 4S squared. Remember what we talked about before. I want to solve for B, and I want to get B by itself, so I'm going to get rid of the S squared here and do away with that, and I end up with 3S squared is equal to B squared. Hold on now, take the square root of both sides. B is equal to the square root of 3S squared. We can simplify that a bit by taking the square root of S squared, and we get S. So S root 3 is the value of B. Did you hear how I made that rhyme? I was feeling good about myself right there. All right, so this right here would be S root 3. S root 3. Now I know it's not super easy to remember. I know it's like, say what? But I want you to notice all three sides have an S in it. The smallest side is S. The largest side is 2S, and the other one is S root 3. Sometimes I look at it and I say 1, 2, 3, just to kind of find some way to memorize the sides. Now the fact is the square root of 3 is not as big as 2, so it makes sense that the side opposite the 90-degree angle would have the 2S, and the side opposite the 60-degree angle would have the S times root 3, because root 3 is smaller than 2, right? And therefore we expect the side opposite the smaller angle to be smaller as well. All right, so these things I want you to memorize. I want you to have memorized this and this one over here. I want you to have both of those memorized. Let's go ahead and try some examples. All right, so here's our example 1, and what we notice is that we have a 45-45 right triangle. And so I'm going to show you a little chart that I sometimes set up to help me answer this. So remember, when we're dealing with that 45-45 right triangle, one side is S, the other side is S in terms of the legs, and the other one is S root 2. Watch what I'm going to do. I'm going to write S, S, S root 2, just like that for the sides. And this helps me kind of organize my information when I'm dealing with these problems. So here, what is the leg length? It's 6. And obviously the other one is 6. They didn't ask me, but now I know that X has to be equal to 6 root 2, right? Side, side, side root 2. So that wasn't too bad. Let's look at this one over here. Again, I have the same situation where I'm given the legs, and that's not too hard. So I've got S root 2. So whatever the legs are, I'm going to put in the S pile. So 9 root 2, 9 root 2. What is X? It's going to be S 9 root 2 times root 2. Do you see how that was a little bit weird? You didn't expect that. When you see the root 2, you think it's going to be S root 2, but no, you need to line it up with what with the measure that it actually is, and it actually refers to the 9 root 2 refers to the legs, whereas the X refers to hypotenuse, and that's what we got there. So X is equal to that. Let me go ahead and simplify. Root 2 times root 2 is 2. 2 times 9 is 18. So X is equal to 18. All right, excellent. Okay, over here, oops, let's see. My bad. Over here, we're still dealing with 45, 45 right triangles, and we remember that the relationship was S, and S root 2, all right? So I'm going to keep that in mind as I process through this problem. So let's look at this guy. So I see that X is here, and the 1 over here would be 12. You guys get what I'm doing? So this is the leg, and this is the hypotenuse. And so the legs are X, and the hypotenuse is 12. But I wish I knew what S was, because that's what I need to find X. All I know is what S root 2 is. S root 2 is 12. Can I solve for this problem? Yeah, I can. If S times root 2 is equal to 12, as it is the hypotenuse, and that's what the hypotenuse length is, I can use this to figure out what S is, which is the leg length. I'm going to divide both sides by the square root of 2. When I do that, I get that S is equal to 12 divided by the square root of 2. You probably remember us dealing with rationalizing the denominator, multiplying by the special gourmet or tailored one. And when I do that, 12 times root 2 is 12 root 2, and root 2 over 2, root 2 times root 2, sorry babies, is 2. Divide that, I get 6 root 2. Are you guys with me? Okay, so let me just break it down. This was not wrong. It just wasn't the typical form that we like to see our answers in. So what we did is we multiplied or rationalized the denominator. What that means is you make the denominator a rational number, not a radical. And so what we did is we multiplied by 1, a special 1 for this situation, root 2 over root 2. If you don't remember this and this seems weird and foreign, let's talk about it when I see you in class. So we get 6 root 2 as our X value. All right, so this triangle is telling us about the 30, 60, 90. And if you don't remember from before, if you didn't write it down, here it is again. When you have a 30, 60, 90 right triangle, the side opposite the smallest angle is always S. The side opposite the largest angle is going to be 2S. And the side opposite the middle angle, the 60-degree angle, is going to be S times root 3. All right, and I like to call it 1, 2, 3, remembering that 2 is larger than root 3, and therefore, the setup is as such. All right, so with that in mind, let's see if we can apply the information here. So I'm going to do just like I talked about, the side against the 30, the side opposite the 60, and the side opposite the 90 can be written like this: S root 3, and 2S. Now that I got that broken down, let me go ahead and see if I can calculate the rest. The side across from the 60-degree angle is 15. The side across from the X, or the side across from the 30-degree angle is X. And the side across from the 90-degree angle is Y. All right? So now that I've confirmed that, with that, I noticed I need to use what I got to get what I want, and the only thing I got is 15. So I've got to use this 15 and the fact that S root 3 is equal to 15 in order to find S and in order to find 2S. So I do exactly what you think I do. I set them equal to each other, and now I'm going to solve. I'm going to divide both sides by root 3. Then we got that. This is technically the answer, but in math, we like things a certain way. I need to rationalize the denominator, which means to multiply the top and bottom by square root of 3 in this case. So I get 15 root 3 over 3, and then that gets me 5 root 3. So S is equal to 5 root 3, which means X is equal to 5 root 3, and y is double that, it's going to be 10 root 3. All right, let me know if you have any questions. I'll talk to you guys soon.